All right, so now this is the first part of chapter 4, which really, all the sections really run together. And so we didn't get too far in 4.1. So I'm going to go ahead and work a couple examples so that when I see you guys on Monday, we'll kind of have an idea of what's going on. So we're going to look at graphing the sine and cosine functions, but we're going to graph them on an x and y plane. And so these are going to be known as periodic functions. And basically what that means is that we're going to have, it's basically going to be like a cycle. Okay. And so, on the unit circle, a complete, a complete revolution is 2 pi, right? And so each cycle, we call it a period, okay? And so these first couple we're going to look at, the periods are going to be a distance of 2 pi, okay? And eventually we'll get into some that are a little bit more complicated to where the period can become smaller or longer. And so we'll see that towards the end of this video. So period, it's just the horizontal length of the interval to complete the cycle. So you're going to want to be really familiar with these right down here. These are the parent functions basically for sine and cosine. So you're going to want to envision your unit circle as you work through all these problems. And basically what we're doing is we're going from 0 to pi over 2 to pi to 3 pi over 2, and then back to 2 pi, which means you're actually going to finish where you started. So let's look at sine. So right here, when you plug in 0 for sine, you actually get 0 back, right? If you look at your unit circle. And then if you plug in pi over 2, which by the way, that's about what, like 1.5 7 or something like that, just so you can have an idea of like visualizing this as an x and y plane. Okay, so when you plug in pi over 2, sine's going to be 1 up here, right? Because remember, sine refers to the y value when you're looking at that unit circle. And then as we go to pi, we go back down to 0. And so you're just following the behavior of y as you go around the circle. So it goes from 0 to 1, back to 0 to -1, and then back to 0. So that's a complete cycle. So that's basically what you're looking at right here. Now, when you look at cosine, it's the same exact idea, except that now you're following the behavior of x. So when you start here, x actually starts out at 1, then it goes to 0, then it goes to -1, back to 0, and then back to 1 where we started. And so that's a full cycle right there. And so if you were to continue going around the circle, you keep getting the same pattern, the same waves. So that's kind of an introduction to this. There's a couple key things here to look at. Just kind of list the domain and range of each one, and then the amplitude. That's something that I guess I kind of skipped over, but amplitude's pretty simple. It's just it's the coefficient in front of the function right here. And so that tells you how high or how low it's going to go, your little wavelengths. And so you'll see an example in a second, so you don't need to worry too much about that. So one thing that you might want to notice is that if you plug in negative x values, what's going to happen is you'll get a reflection across the x-axis when that happens. Because basically what's going to happen is on your unit circle, you'd go in the opposite direction. So you'd go in reverse. So you start out here at sine is 0, then it goes to -1, then to 0, and then up to 1, and then back to 0. So if you plug in, if you go in basically if you're going clockwise, then the sine values, you're going to go in the opposite order. Okay. But cosine, it doesn't really make a difference. So whether you go clockwise or counterclockwise, it's not going to affect the cycle. So cosine will still look the same. It won't actually affect that. So anyway, something that we'll run into here and there. It's not a big deal. You should recognize it when you start to build a table or whatever. All right. So let's try one of these. Let's see if I can move down here a little faster. Let's see. There we go. All right. So this first one, basically you're looking for the 5 key points. And if you go back and look at the graph up above, you'd see the 5 key points. But I'll go ahead and do the unit circle again real quick. So basically what your 5 key points are 0, pi over 2, pi, 3 pi over 2, and then back to 2 pi. So if you notice, I listed 5 values for theta. And it'll get more complicated at times, but like we'll just wait until we get to those. Okay, so on this first one right here, cosine of x, okay? So right now, we're going to start out pretty easy, so we're just going to keep plugging in 0, pi over 2, pi, 3 pi over 2, and then 2 pi, okay? And so when you plug that in, you just want to look at your unit circle and just go counterclockwise around it. What happens to x? X starts at 1, goes to 0, to -1, back to 0, and then back where we started at 1. All right, so then now we're going to want to build our graph right here. And so we're just going to rough sketch this. So we'll put a 1 up here, -1 down here. And then for the most part, I'm always going to go by these, the scale factor right here of 2 pi. So every unit is 2 pi, so that takes me to a full pi, 3 pi over 2, and then to 2 pi right there. And so this one, and this is the one that's in the graph up above, so you could just look up there if you need help drawing this. But so we got a point at 0, 1, then at 0, then down to -1, and here, and then up here. So we're going to go like this, and like that. And there you go. And so if you look up above, you'll see that's the parent function. So what we're going to investigate here is, well, we throw a 2 out in front. So what that's going to do is it's going to basically affect the amplitude. And so the amplitude is just how high or how low it goes. And that's basically it, okay? So you're going to get the same results, except you have to double it. Your y value is equal to twice of what cosine of x was from the other function. So we're still going to plug in 0, pi over 2, pi, 3 pi over 2, and 2 pi. And so the only thing is that when I plug it, these results get doubled. So this becomes 2. When you double 0, that just stays 0, -2, 0, 2. And so let's go ahead and graph this one here. So let's see, I guess I need to adjust this a little bit. We're going to go a little bit higher up. So we'll put a 2 up here, and we'll put -2 down here. So I might run into my graph a little bit, but that's okay. All right, so let's see. So we're going to start up here. Then we have the same x-intercept, and then I'm going to dip a little further down. Now I'm going to come back up, and then I'm going to finish where I started at the same height. And so make sure you draw this with some curvature to it, okay? Just think of the kind of curves like a circle, kind of like our unit circle over here, because that's the behavior we're following. All right. So if you need to, you can watch this over again if you need to see the second time, but I'm just going to go ahead and move on. Here's another example. It's of sine, and the amplitude is just going to shrink by, like, it's not going to go as high. It's actually going to go shorter. I'm going to go ahead and skip that example. You can look in the notes and try to work it out on your own. Same thing with example C. If you want to look, I've already posted the notes online. You can see what does that -x do to the graph, and so you can look at that and you'll see what happens. But I will go ahead and do part D. So let's see. Part D right here. So we've got sine of x. Let's see, x, y. So let's see. 0, pi over 2, pi, 3 pi over 2, and then 2 pi. And then you're just going to visualize the unit circle going counterclockwise, starting at the 0 position for radians. And so sine is 0, then it goes up to 1, back to 0, then to -1, and then back to 0. This isn't malfunctioning on me. All right, so we'll go ahead and graph this. So once again, we'll kind of build our generic graph. So this will be 1, -1, and we'll go by, our increments will be pi over 2. So pi over 2, and then pi, 3 pi over 2, and then 2 pi. So there we go. All right, so let's go ahead and graph this first one. So let's see, at 0, 0, we start out here. Then at pi over 2, we go up to 1, then back to 0. Then we dip down to -1, and then at 2 pi, we go back to where the cycle began. And so we go like so, and there we go. And if you were to continue it on, I mean, it would basically do the same pattern. If you really wanted to keep it going, it would look like that. So, okay, so let's see what happens if we throw a negative 2/3 in front. So what's going to happen here is the 2/3 is going to cause it, the amplitude basically is going to be 2/3. Okay, so that means that that's going to be how high and how low I go from the center of the graph. Okay, see this, what the original one was 1, went 1 in each direction. So this one's going to not quite go as high and not quite as low. But then that negative is also going to kind of complicate things a little bit. That negative right there is going to, it's going to cause us to do a reflection across the x-axis. So let's see that. All right, so we got our x, y. Once again, we're going to plug in 0, pi over 2, pi, 3 pi over 2, and then 2 pi. And so, oh, this is going to be frustrating. Okay, sorry about this. Okay, stay. All right. All right, so what we'll do here is basically all these results, you know what sine of x is. Sine of x is just getting multiplied by -2/3. So you can take all these results from this table and basically multiply it by -2/3. So it's just, I want to emphasize, it's going to be really important just to know the parent functions for sine and cosine, because then when you look at the transformation, you just apply it to what you know about the parent function, okay? All right, so 0 times -2/3, that's just going to say 0. When you multiply it by 1, it's going to be -2/3. When you multiply it by 0, it's going to be 0. When you multiply it by -1, it's going to be negative times a negative. It actually becomes positive now. And then when you multiply by 0 again, you get 0. So let's see how this one's going to look. So we're going to start at 0, 0. Then we're going to dip down, not all the way to -1. We're going to go 2/3 of the way, about right there. Okay. And then we go back to 0. And then we're going to go ahead and peak at 2/3 of the way, about right there. And then we're going to finish off at 2 pi right there. So we come down, oh, try to draw this accurately. Here we go. So you can see what the transformation did here. So, you know, this might seem a little overwhelming, but I suggest you start trying your homework, because the homework is going to be multiple choice for the most part. Not all of it, but most of it is. And so that'll help you kind of get a better grasp of it. And so anyways, all right, so I'm going to go ahead and stop here, but then I'm going to make one more short video and just work out a couple more examples. We're going to look at period. So we're going to look at what's going to happen if we change the cycle. Maybe the cycle takes longer, maybe it takes less time to actually complete a full cycle. And so anyways, all right.